Well, hi everyone. It's great to be here in Galway. I'll just give you a few moments to go over the shock of he's going to speak for an hour. Yeah. What I thought I might do is, it may not take an hour. So there is a crumb of hope for you that it may not take an hour. And would people feel shortchanged and ripped off if you got a slightly longer coffee break? I'm not picking up any vibes that would be an issue. So it will take as long as it takes. We're up to an hour, but I'll try not to take any more than we need to on this. Also, what I'm going to do is I'll show you various examples as we go through. So I've got my laptop here at the front, connected via Zoom to the desk at the back. What could possibly go wrong with something like this? There's a little bit of jeopardy there for us to get excited about as we go through. And what we're basically going to talk about, as you can see it up on the screen behind me, you can look at the question really, how secure, I suppose, is the public cloud? I mean, if you were to give the public cloud a rating out of 10, how secure is the public cloud? What would you say? Yeah, you'll have an opinion, I'm sure, on that. Yeah, and we're going to explore how secure the public cloud is. That's what we're going to be looking at. We're going to look at some examples of where people have really, frankly, messed up, and we're going to look at some examples of how you can apply some really good practices and have a very secure application. We're going to look at the whole gamut as we go through. Just to say very briefly, who am I? Why am I here? Why have I come over from Bristol? So I'm a technical instructor, I suppose, one thing I do. So I've worked with AWS, actually, and teach most of the official AWS courses and have done for about 8 years. So I do a lot of that, worked in places like the BBC. I've been a cloud architect for IATA projects, International Aviation, if you're familiar with those, International Association, Transport Association, that's it. So I worked with IATA. I was the cloud architect for a project that's just been going live now, actually, cargo-focused project. And I'm a pilot as well, so it fits in with what I do. And work, as I said, in different domains. I work in, obviously, aviation, also do a lot of work in finance. I've been down to Galway many times, actually, over the last 20 years, delivering training programs in some of your organizations over time, looking at things like Java and Agile and stuff like that. So I do a lot of sort of teaching stuff as well. Nuida, just briefly, they're one of the sponsors, aren't they? So just very quickly, we're a training provider, primarily enterprise learning, early careers, e-learning content, that kind of thing. That's what we do. Work with various different clients you can see on the list there. And what I'm going to talk about, here's an overview of the kind of things we're going to pick up on in this session. So you can see them on the screen. So when we get to securing data, you think, thank God. Yeah, so we'll begin by looking at security just generally. We'll look at auditing, access to cloud environments. We'll look at infrastructure. So how do we audit our infrastructure? What sort of mechanisms do we have? Auditing our infrastructure perhaps even before we've deployed the infrastructure. Why find out the infrastructure's flaky once you've deployed it? Wouldn't it be easier if you could find out the infrastructure was flaky before you even created it? Yeah, so we'll have a look at some of that as we go through. We'll talk briefly about DevOps and DevSecOps as well. So how we bring security into our pipelines. We'll look at application architecture as well, security for the applications themselves and the data, securing our data in our cloud environments. Okay, so that's the plan. So is the cloud secure? Here's a few news articles that you may have seen over the years. My favorite, I'll be honest, is this one. Anyone seen this one? Yeah, I think, what did you say? If you get your security wrong in the cloud, you may as well pack up and go home. Yeah, this company almost did. Yeah, so let's paint the picture for you. They'd employed somebody who worked in their cloud environments. It's a company, they employed this guy. He was a bit hacked off when they fired him. Yeah, so he thought he'd get some revenge. So what he did is he logged in to the corporate cloud account using the credentials of someone else. And don't get any ideas, by the way. This isn't. It's just giving you, just painting a picture. So he logged in to the company's cloud account with somebody else in the company's credentials. Someone called Speedy. It's a great name. Now, so logged in with Speedy's credentials, and then decided to delete various databases in the cloud account. And you can see, if you can see the headline up the top there, does it say 500,000? Yeah. So you hit delete on £500,000 worth of business critical data. So there's an example of how it can go a bit pear-shaped for you in the cloud. Now, we can look at this. It's a fascinating little article about what happened. Yeah, so here it is. You can see £500,000 worth of business critical data. They lost significant numbers of clients and had to make redundancies. So pretty serious. He was sentenced to a couple of years in prison for doing this. Now, we're going to have a look later at how they caught him. Because this guy, he wasn't... Yeah, I mean, if you were going to do something like this, there are some things he could have done to avoid, maybe. Well, we'll have a look anyway. We'll see how he got caught. But there's an example of a company that almost went under because, well, not because, but they were in the public cloud and they were part of that 30% that's in the public cloud and they almost went under. Another example, this kind of thing I'm sure you've seen before. Who's seen examples like this? Company post a whole load of mission critical data on the internet. That's how it normally reads, isn't it? Have you seen those articles? Companies put all their customer data on the internet. It was there for 3 years. You know, those kind of articles. This is one of them. Yeah, so this is WWE. Anyone into wrestling? One person nodding over there. Yeah, so WWE, they had a data breach, one of these examples, and it's again a misconfiguration in their cloud account. You hear these kind of stories, you read them, don't you? There was a big telecoms provider did it as well, Verizon, I think it was, in the US, had something similar. You know, there's a number of these examples, aren't there, where companies put their data, or somehow, as we'll see, end up with their data getting exposed on the internet. So coming back to the question, is the cloud secure? Yeah. The answer is, obviously, it depends. Because in these cases, it obviously wasn't. Because it didn't work out too well for those. Here's another quote. Here's a quote pushing it the other way. So Capital One Bank. Yeah. So this is the CIO of Capital One Bank. We have successfully exited all of our data centers and gone all in on AWS, enabling instant provisioning of architecture and rapid innovation. We are now able to manage data at a much larger scale and unlock the power of machine learning to deliver enhanced customer experience. On AWS, our technology teams are free to focus on what they do best, building great software and delivering innovation to our customers. He's also on record as saying, one of the reasons we moved to the public cloud is because it's more secure. Yeah, which is an interesting thing for him to say, isn't it? More secure than on-premises. Again, you might have a view on whether he's right or wrong, but that's what for better or for worse, that's what he said. So, security in the cloud. How does it work? How is it shaped? Fundamentally, it's a shared responsibility. Yeah. So there's onus on the public cloud provider, whoever you're using, Amazon or Azure or whoever. They're responsible for some of the obvious things, I guess, securing the data center or data centers, securing the services that they offer. You know, so if they offer a service that does X, Y, and Z, that's the cloud provider's responsibility to ensure that service works. For example, the cloud providers will have options to restrict what ports are open, for instance. Yeah, you would imagine if you configured certain ports to be open, they would be open. And you would also imagine that all the other ports are not open, wouldn't you? And you kind of trust the cloud provider to do that. Yeah, so there are responsibilities on the cloud provider like that. Yeah, but then you have your responsibilities as well. And this is where we saw some examples of people not perhaps reaching the bar. So you are responsible for using the various services that the cloud providers offer correctly. Yeah, so the cloud providers might let you open certain ports on computers. Yeah, so making certain things available on some kind of computer you've got running. But they'll also let you open every single port. Any IT security people in the room? You can put your hand up. Permission to put your hand up. Is it that same? No. Yes. But that's not a good thing, is it? Opening all the... even if you're not, you get that doesn't sound good. We don't. The cloud provider will let you, but it's down to you. You decide how you want to use it. You can use it in a stupid way if you want to. The cloud provider won't stop you. Yeah, it's up to you. Yep, so use the services correctly. Put the correct security settings in the services that you use. And also have effective use of monitoring and reporting. So the cloud providers will give you all sorts of monitoring. I'm going to show you some examples in a moment of the sort of services you'll get from the cloud providers that give you the ability to monitor what on earth is going on, so you know what's going on. So you can do things in response to things that are going on, or even better, automate the responses to things that are going on in your cloud environment. But fundamentally, it's a shared responsibility. So you could, if we just come back to the basic question, is the public cloud more secure or less secure than on-premises? The best answer, which sounds like a cop-out, but it is probably the best option, is it depends. It depends. If you use it properly, it's going to be very secure. If you don't use it properly, then it won't. Which is a bit like on-premises, isn't it? If you do things on-premises properly, it will be secure. And if you don't, it won't. Yeah. Then you have another question, which is who's probably going to do a better job of the security? This is a contentious question. You'll have a view. Yeah. So are the cloud providers going to do a better job of securing their data centers and so on? Or are you going to do a better job of securing your data centers and so on? It's a good question to ask. At the BBC, about 8 years ago, when they transitioned to the cloud, I've been working at the BBC for many, many years, about 20 years actually, on and off, and they migrated to AWS about 8 years ago roughly, and I remember being in various contexts where people would say things like, but what if Amazon goes down? What if it goes down? All the BBC stuff is going to go offline, just like that. People won't be able to watch EastEnders on iPlayer, just like that. Yeah. But actually, you just turn the question around and say, well, yeah, that's true. But which is more likely to go down? Amazon or you? You're a media company. You do media, that's what you do. You happen to have data centers, but you're a media organization primarily. Whereas AWS, Microsoft, Azure, etc., they're data companies. Are they more likely to go down, or are you more likely to go down? Again, you'll have a view perhaps with your own context, what you think. I mean, different opinions are on that, but certainly for a lot of organizations, actually, more likely to have some level of resilience in the public cloud, perhaps, than in your own environments. So security concerns. Let's have a look at some of the security concerns that we can address. So the accounts themselves, your cloud account. So I'm going to use as my examples for this AWS. Yeah, this isn't sponsored by AWS or anything like that. I'm just using it as some concrete examples so you can actually see what I'm talking about. Because often, people say, oh, you can do this in the cloud, you can do that in the cloud. But it's quite nice, I think, to actually see what we mean and show you some actual examples of what we're talking about. So I'm just going to use Amazon to do that. So I hope that's okay. But other cloud providers are available. Just put that massive caveat out there. Yeah. And they're also very good. Yeah. So with Amazon, for example, who just got their personal cloud account? Either Amazon or Azure or anything like that. Who's got an account? Anyone? Yeah, quite a few of you. If you wanted to get one, you could create, all of you, everyone, if you've got a credit card, this afternoon, you could open your own cloud account. Yeah, and if you're interested in cloud computing, this is a total aside, nothing to do with it. But if you're interested in cloud computing, I would recommend having a go at doing that. Just open it at Azure, Microsoft. Azure is quite good because you can put a limit on the cost. Because the scary bit is, well, anyone done it recently? There's one scary moment when you go to open your own cloud account. It's where you put in your credit card, but you don't put in the amount you're going to spend. You just put in a credit card. And then anything you use goes on your credit card. And your immediate fear is, I'm going to accidentally do something super expensive. I mean, that's that's my immediate fear. I was going to do something really expensive. Good thing about Azure is you can put a limit on the cost, so you just stop. So as soon as you hit the $5 or whatever, as soon as you hit the limit, it stops. Yeah, but it's worth doing that if you're interested in the stuff we're going to be talking about today, cloud computing. Yeah, have a cloud account, open one up, and try stuff out. Yeah, but if you do open an account, you have a username and a password, but you never, ever use that. You keep it literally under lock and key. So various companies I've been in, I always ask them, just because I'm nosy really, where do you put your username, password, your root account? And you get all sorts of answers. Oh, it's in a filing cabinet on the 4th floor, on the bottom shelf, locked, in an envelope. That's what, I don't know why I remember that one, but I do. So they literally locked it in a drawer in a filing cabinet somewhere. Yeah, so you never use those root credentials. And the reason you don't use them is because if anyone logs in with those root credentials, what could they do? Root credentials. What do you reckon you can do with root credentials? Everything, yeah, literally anything on your credit card, which is very nice, isn't it? so that's great for people who want to get hold of your account. Why would they want to do that? Bitcoin mining or who knows what, but basically it happens. Yeah, so we keep that root account locked away. And what we do, what the Amazon provide and the other providers have similar mechanisms, is we provide mechanisms for access for our workers and people who work in the cloud space. So we always use those to access. It's like Cloud 101, this is, in terms of security. This is fairly basic stuff. For those of you who are familiar with cloud, you'll know much of this already, I'm sure. So we use some kind of service to regulate access to the cloud. And then what we also do with this regulated access is we turn on MFA, multi-factor authentication. Let's think back to our £500 million dodgy Steph Needham character. Yeah? Let's go back to him. Why do we need MFA? Well, here you go. In the article, it even says, can you see that? I don't know if you can see that from where you're sitting. Yeah. If they had implemented multi-factor, yeah, it wouldn't have happened. Yeah. It's a cautionary tale, isn't it? I'm sure many of us have. Do you have MFA on our accounts for things? Yeah, many of you will do. It's worth putting it on for your cloud. It's worth putting it on for anything, to be honest. But it's worth putting it on for our cloud environments. Because if they'd put that on, this case wouldn't have even happened. Yeah. So we secure access to our cloud accounts. Because it's through our cloud accounts we can do all the things we want to do in the cloud. Who was here this morning for the AI stuff? Anyone here this morning? It was fascinating, wasn't it? Really interesting. And the amazing thing is, in the cloud providers, you can do a lot of this stuff as well. We talked about ChatGPT, but the cloud providers themselves offer all sorts of AI services. You sign up for a cloud account this afternoon, you could be using AI with high-performance computing and all the rest of it by tea time. Yeah, because you've got access to all of that within your cloud account. So we don't need to get into all that. Now, it's also a shared responsibility model, so let's think about some of the other things that you perhaps are responsible for in your cloud environments. One of the things you'd be responsible for is maintaining all your servers, if you're running servers, that is, in the cloud. Yeah, so patching servers, doing updates on servers and things like that. That's all the responsibility of the customer. The scary thing is, when I ask a question on the sort of official, cloud courses that I run, I don't put it up like this. I just ask the question. I should have done it with all of us, perhaps. I didn't think of it. But I just pose the question, if you launch servers in the cloud, who's going to sort them out in terms of patches? Just ask the group, just around. Who thinks you're going to do it and who thinks Amazon's going to do it? You just ask the question. And nearly every single time, the majority think that Amazon's going to do it. Nearly every single time, without exception. They all go, oh yeah, Amazon will do that. And I find that slightly scary. Because you think, if they take that view into their work and they launch some servers in the cloud, and they're going, oh, Amazon will patch them, fantastic. Yeah, that means you think Amazon are doing it, Amazon think you're doing it, so who's doing it? No one, yeah, there we go. We need to know, with these shared responsibility models, you do need to know, hang on, what am I responsible for? And what is the cloud provider responsible for? It's part of we need to educate ourselves. What does the cloud provider do and what must I do? We need to be clear. Yeah, because if we're not clear, bad things can happen. Just like with your own personal computers. When you get the updates, if you put them on, I do my Windows updates once a year. Yeah, we perhaps don't do that because we want to make sure our machines are secure. And it's the same in the public cloud, but it's your responsibility, remember, to sort that out. There are services to help you. So the cloud providers have services where you can just sort of click, update my machines, but if you don't use the service, or you can automate it, obviously, then it won't happen. Yeah, so you're responsible for securing servers. The cloud provider, I'm talking about Amazon, but it'd be the same on Azure, no different. Yeah. All the networking and routing for your machines and things like that, you set it up, but it's the cloud provider's responsibility to ensure that it all behaves as expected. It would be a bit of a surprise, wouldn't it, if you logged into a cloud-based computer. Imagine logging into your own computer at home, and suddenly you see another drive pop up for your next-door neighbour's computer. That'd be weird, wouldn't it? C drive, oh yeah, D drive, next door. Yeah, unusual. Yeah, we wouldn't want that in the cloud either, would we? You know, you're on your machine in the cloud, and then, oh, there's someone else's machine in the cloud. We wouldn't want that to happen. Who stops that happening? Well, that's the cloud provider. You've got to, in the end, trust that the cloud provider, when they say we ensure separation of our virtual machines, you have to trust, in the end, you have to trust them that they're going to do that. Yeah. If you don't trust them, then don't be on the cloud. Yeah, so you trust the cloud provider to implement that. It's their responsibility. The data centers themselves, the cloud providers won't give you a tour of their data centers. That's what they always said to me at Amazon. You know, we don't give our customers a tour of the data center. It just doesn't happen. Now, one of you is going to say, I did a tour. But apparently, they don't give anyone a tour. Yeah, they didn't used to publish the addresses. You didn't even know where they were. WikiLeaks paid to that, actually. They did publish them. But Amazon never published, where these data centers are. They don't. Amazon are responsible. The cloud provider is responsible for that security, and they implement that for you. How can we secure our infrastructure? Yeah, so let's move on from the basic securing our accounts. What about the infrastructure that we need to run our stuff? For those of you not familiar with sorry, it's a bit techy in places. For those of you perhaps less familiar with the technology terms, the infrastructure is like all the, well, I suppose a picture of it there, all the it could be pizzas, couldn't it? A pizza rack for all I can see, very small. But it's a server rack. So it's basically computers all plugged in together. It's the infrastructure. Yeah. Now in the cloud, your infrastructure is, from your perspective, most of the time, is just software. So you're not provisioning any physical infrastructure. There are some cases where you do, but broadly speaking, everything you do is code, sometimes referred to SDE. Anyone heard the acronym? SDE is a new one. You can bandy this around if you want to work. SDE, oh, we do SDE. It's software-defined everything. Yeah, so in the cloud, it's software-defined everything. Everything you do is software. If you need a network, you're not scrabbling around on your hands and knees under the table trying to plug wires in. It's software. If you need more computers, you're not running off and grabbing some physical machines and plugging them into a rack. It's just software. Everything is software. Your infrastructure is therefore software. So if you need a network, what is that? Well, it's just software. So if you need to reconfigure the network, well, you just change the code and rerun it, and it changes the software. So another acronym, which perhaps more of you be familiar with, IAC. You can probably guess what it is from up there. Anything look like IAC? Yes. Infrastructure as code. So all the infrastructure we need is codified. You can see a little snippet of some code there. There's different technologies that are used to do this. Anyone use Terraform? Terraform in the house? Terraform, yeah, we have 2 Terraform users. Any CloudFormation users in the house? Yep, few. CDK, oh, a few more, yeah, CDK. That's CDK on the right if you're interested. Cloud Developer Kit. In a sense, it doesn't matter primarily which one you use. The important thing is you're using something. Yeah, so what we want to do is when we want to create some infrastructure, like a network with some machines or whatever it is, we use a script to do it. Yeah, Amazon have a console. In fact, Azure, Amazon, all of these cloud providers, they have web consoles. Yeah, they look like this. And I can go clicky click, clicky click, can you see that? And I can create things. So like VPC networks, so I could go in here, I could go clicky click, oh, we'll have a network, clicky click. But the problem with that is what? What's going to be the problem if every time we need a network we go clicky click? What could possibly go wrong? Permission to answer these questions. It's not just, what do we think? What could go wrong? Exactly, repeatability. Yeah, you can go clicky click and get it right. You think, whoa, that's good, I got that right. But then you need to do it again. You need to do the development environment, the user acceptance environment, the production environment, and then whatever other environment you might have. You need to create the same thing over and over. Yeah? So we want repeatability. So we want to automate it. If you let people do it, you'll get errors. In finance, they call them fat finger errors, don't they, sometimes? Have you heard the term fat finger error? So it's typically where a trader accidentally buys or sells far more stock or whatever than they anticipated. A fat finger error. These things can happen in the cloud. There was a case at Amazon, actually. I think it was a couple of years ago. Anyone remember? I think roughly a couple of years ago, AWS had a major outage in Virginia. Anyone remember that? Anyone? Yeah, they had an outage anyway. The Amazon stuff all went a bit wrong in Virginia. And whenever the Amazon stuff goes a bit wrong, they always do a bit of a sort of a, post-mortem, thank you. Yeah, they do a post-mortem and then they publish, what happened. It turned out this particular issue was a fat finger error. So someone at Amazon said, we've got too many or not enough, or whichever way around it was, servers to do a service called S3 that some of you have used before. So they thought, we need to remove a few, but accidentally add an extra 0 or 2, something like that anyway, and removed a load of service which caused S3 to go down. And those of you who work with Amazon, S3 is a pretty fundamental service. If S3 goes pear-shaped, lots of other things then go pear-shaped around it, which is what happened. Yeah, but it was an error caused by a human. And then they said, right, we're going to automate that, never going to let that happen again. Yeah. So we automate our infrastructure. That's one of the very important things that we can do. Terraform is one way, CloudFormation, CDK, SAM, various technologies that allow us to automate the infrastructure. Yeah. Very important aspect. And it's security related. Yeah. Because, remember I said earlier, why don't you verify the security of your infrastructure before you even create it? Yeah, so in a physical data center, you'd plug in, or you'd make a plan, wouldn't you? Yeah, you'd plug in, you'd work out, for security we need boom, 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 boom. You'd plug it all in, and then you'd probably hopefully test it and make sure that it meets whatever your security requirements were. Yeah, but you'd have to set it all up and then test it. But in the cloud, why don't you test it while it looks like that? You haven't created anything. You haven't even run the software. Why do you need to run the software to create the infrastructure in order to test it? Why don't you test it while it's like that? Yeah. And there are technologies around that do that. Yeah. So anyone heard of SonarQube? Some of you probably use it, don't you? Does anyone use it? Yeah, a few of you do. I'm not surprised. Yeah, so in the aviation project I was doing, we used infrastructure as code for all the infrastructure, unsurprisingly. And anyway, so it was all in Git, in our source bucket and all that. And we had SonarQube running every time. And I remember this because it was me who wrote the thing. So I wrote one of these cloud, infrastructure as code. And then SonarQube is kicking off. You have not secured your message queue. Don't you think you should be encrypting your message queue with KMS, which is a key thing, encryption things. Yes, I probably should. But it never even got to being created. Do you see what I mean? It never got past the sanity check of some technology that was reviewing my infrastructure before it even had been deployed anywhere, even into dev or anywhere at all. It was verified. Sometimes they call it shift left. You're checking stuff early in your pipeline. Yeah, so think of a pipeline, where you go through a process of building something, testing it, deploying it, etc. Well, as part of that pipeline, as part of testing it, you could be verifying that this stuff is all right, from a security perspective. So you can check the security of your infrastructure before you even do it. So shift left, as I just mentioned. So moving some of the testing to earlier, you might have heard, has anyone heard this phrase before, shift left, shift right? Some of you will have done, So moving a lot of the testing earlier. Yeah, and one of those things we can move, there's many things we can move, but one of them is the security, as an example, security of our infrastructure. Yeah, we can be verifying it. Here's a screen, this is a shot, this is actually from the Sonar Cloud homepage, actually, but it's just an illustration of what I'm talking about. It's saying, I don't know if you can see what that says, but it's a bit of infrastructure as code, and Sonar Cloud has looked at it and said, oh, it didn't say, missed that bit out. But it just says, make sure granting access to all resources is safe here. So there's obviously something in the infrastructure as code saying this is going to be accessible from anywhere, and the validator, the verifier, is picking that up. Yeah, so it's telling us before it even goes into any deployment whatsoever. And then we can shift right. We will still do tests on the actual environments themselves, security tests and so on. It's not like we just, we've tested it when it was, just sitting in Git. It'll be fine. We verify that, don't we? We test it as well when it is actually built. So, but we're just reducing the chances of our failures and vulnerabilities getting downstream. Do you understand what I mean? So you're picking up the issues far earlier. It's better to pick it up when it's sitting in Git, isn't it, than when it's out there with the customers using it. Yeah. So we want to grab it or pick up those issues as soon as we can. And we can look at the resilience of our infrastructure as a shift right. Yeah, we don't need to get into that now. But it's all part of the pipeline. This is all part of a DevOps pipeline, or DevSecOps, we build security into that pipeline. Yeah, security in the pipeline, so are we doing these kind of checks I'm talking about in the pipeline? Obviously, there's another issue, which is the security of the pipeline itself, which is something else we have to consider. And again, there's so many tools for DevOps, aren't there? Don't you find that? There's just so many different tools. But whatever tools you're using for that pipeline, whether it's Amazon, Azure DevOps, GitLab, etc., there's loads of them, aren't there? Whatever you're using, you're building security into that pipeline. And then what about the data? Securing our data as well. We are also responsible for making sure that we've got the relevant permissions on the data that we're storing. And again, the cloud providers give us all sorts of ways of securing our data. So a bit like earlier this morning, we're talking about AI, weren't we? Talking about our machine learning from the data set and so on. Here's the question, where's the data set? Would you put the data sets in the public cloud or not? It's an important question. I was with a big financial institution last week one of the guys just made the comment. He said, oh yeah, we don't put any of our data in the public cloud. Any of it is too valuable. None of it. All on premises. So there's just, without exception, almost proud of it, like badge of honor. None of our data is in the public cloud. But then other organizations, everything's in the public cloud. So everything is in the public cloud. Everything is in the public cloud. So you get different opinions on where it can go. But if you are going to put your data in the public cloud, you need to ensure that it's secure. If you've got databases, you need the right permissions on them, obviously. That would be true on premises as well, wouldn't it? No different. But it needs to be encrypted. You need to think about permissions. We talked earlier about zero trust. So you put the permissions on a database that might be that only a certain application can ever access the database. No other application can access it. So that if it's a different application, can't access the database. So we need to ensure our data is secure. Permissions on our S3 buckets, see that on the right-hand side? That's probably the one that's most high profile that we see in the news. That's like we saw WWE, the wrestling one. That's the one on the right. Accidentally put I saw one just recently, there's a big medical institution in the US, dental. Was it dental? No, it was some I can't remember, it doesn't matter. But anyway, all their patient data, this was just recently, was in a storage area in the cloud, accidentally made it public. The cloud providers, incidentally, are making it harder and harder to make this mistake. I don't know if any of you have noticed this, just anecdotally, but if you use Amazon years and years ago, if you wanted to create one of these storage areas, you go clicky, clicky, click, storage area, public, tick, boom, done. Now, if you tick, public, it's like, are you sure? You need to tick another tick to say you've read the thing that says you're sure that you're sure. Or you create it and say, I don't want it public and I don't want it ever to be public. And if anyone ever tries to make it public, don't let it work. So the cloud providers now make it harder and harder to make this mistake but we can see it actually. Let's see it. So let's go into the console. Obviously, normally you do this stuff by infrastructure as code, but just to show you what I'm talking about. So this is the S3 service. So storage, unlimited storage in the cloud, essentially. So if I create a storage area, give it a name, there we go. So I give the thing a name. I can choose where in the world it goes. And then I've got all this stuff about, look at this. See that? Block all public access. Now, can you see it didn't used to be there? You didn't have to worry about that. It is now. If I deselect it, see the red triangle? Are you sure you want to do this? This public could go public in the future. Because what happens in these examples, you know, like the WWE wrestling, you think, oh, they must have been so stupid. How did they do that? That's what you think, isn't it? You think, oh, I wouldn't do that. And you probably wouldn't. But what happens is somebody creates a bucket with the data in, it's all private, all good. And then someone else comes along and think, oh, we need to make this public. Or they oh, it'd be all right to make that public. And they tick the public box, either through a script or manually, like you can see here, and they make it public. Nobody notices. Because all they did was tick a box. And that whole storage area is now on the internet, if people can find the links and all the rest of it. And all they did was tick a box, and it's all online. So this now, do you see what I mean? This will stop that. This will stop the idea. Well, it makes it harder. You've got to tick a few more boxes now, to accidentally make something public. Lots of box ticking, to get this thing to be public. So you can see the kind of thing that the cloud providers are doing to try and reduce the risk that you'll put your customer data online. The other thing, actually, interestingly, Amazon have done, this is Amazon specifically now, just recently, does anyone know what they've done with S3? Bonus points for anyone who knows. What have Amazon done? They've changed the default configuration now for buckets in S3. It happened about a month ago, 3 weeks ago. Anyone know? Something is on by default that used to be off by default. It is, very good. Encryption. So it didn't used to be encrypted by default. You stick your stuff in these storage areas. By default, it's not encrypted. Now, by default, encrypted. You can turn it off, obviously, but the default now is encryption. We probably see that in the... There we go, default encryption. You see that selected, enabled, you see that? And if you did it through a script, create a bucket with a script, it will be encrypted unless you say no. It's a change, recent change. So to secure data, Amazon are responsible for things. You are responsible for things. Does that make sense so far? Happy with that? So there's various encryption options. I won't go through the minutiae of it. You'll probably lose the will to live if I do that. But there are different encryption options. You provide the key, Amazon provide the key. You have the key in a special key box in the Amazon data center. Various choices about how the keys are stored, and you decide what works best for you. Another service that's quite useful, this is Amazon specific as well, but very useful. If anyone responsible for their data in their organization, anyone have that on their job description? On the job description, you are responsible to make sure that none of our customer data is ever placed on the internet by mistake in any way, shape or form. That's on your job description. Anyone got that? If you did have, if that was in your list of responsibilities, you would like this. So it's just a service that the cloud provider offers. And what it does, is it says up there, is if you turn it on, you tell it about personal identifiable data within your organization. So say your customers all have an ID number, 10 digits long with a couple of letters at the end, for instance. You tell this service that, and it just scans all your data in buckets and storage areas and says, oh, you got some over there, you got some over there, you got some over there. Oh, and by the way, that one over there, public over there. Did you know it was public over there? It's been accessed from over here. Did you know over there it's been accessed from over here? So it's telling you about your data and how it's being accessed. So it's a very useful, it used to only be available in the US, but recently they've rolled it out more widely. So just services like that you can take advantage of to help you in terms of your data. Other services we can use, so we just look at some examples now of the kind of services that the cloud providers offer, just to give you some concrete examples. Some of you will be familiar with this service, I expect. Who's familiar with this one? So I'm pointing at the screen. This is a screen, by the way. It looks like a nice product. I'm pointing at this. Doesn't help you, does it? Who's familiar with this one? Cloud Trial. Some of you are. expect you would be. So this is what they used to catch that guy who did his £500,000 worth of damage. Because if you look at the article again, how did they get him? Did you see what it said? It was traced through his IP address. So, how did they do that? Well, CloudTrail logs every single interaction with your account, with your cloud account, and just logs it. Everything anybody does, logged. Remember he logged in as somebody else? Yeah. So it was in there as Speedy. So it was in there as Speedy. Speedy deleted this database. He deleted that database. He deleted that database. All in there, in the logs, in CloudTrail. And if I go to CloudTrail, we could have a look what's been going on right now. So we could see it. This is what it looks like. And again, you can automate all the interactions with this service as well, just like any other. So where are we? We're in Ireland. Yeah, let's have a look at the history, what's been going on in this account while I've been talking. Yep, so, that's me logging in, look. 1:28, I logged in. Yep, so there's me. I've logged into the account. Various other things have been happening since I logged in. So we can see every axis. If I look at my login, for instance, let's find that. Console login, here we go. Here's the event. There's the IP address. You see that? If it's at the back, there's an IP address if you can't see it. So basically, the information about my login is there with the IP address. This can be really useful, this service. So they used it to catch the guy. The funny thing is about the story is, guess where the guy was when he logged in to delete the databases? He was sat at his desk at his new job. And that was the IP address of the company he'd got his new job at. So, a bit stupid, but that's what he did. So that's how they tracked him, though. CloudTrail, there's the event, there's the IP address. Right, where's that IP address? Police involved. Oh, that IP address is that company there. Who's in there? Oh, recognise that name. That'll be the guy who did it. Yeah. So CloudTrail is a really useful. So you should always turn that on if you're using, Amazon specifically, and Azure has similar services that you can take advantage of. Also, we can look at our environments as well. So what if your environment has changed? Your resources, your infrastructure has changed. It's all very well to check that your infrastructure is secure when it's in source control. Remember we said about that? Infrastructure is, it's all fine. It's fantastic. It's been verified. Green ticks all over Sonar Cloud. Everything's good. But what's to stop someone going into your cloud account and changing the configurations? Oh, I don't like the look of that. I'll change that. Some well-meaning developer. Oh, I'll change that. Oh, that doesn't look right. I'll change that. Yeah, junior developer might make that sort of error. I remember a junior developer years ago. He was working on a Java app, and he saw. So this will only make sense for the Java people. Just for a second, though, just humour me. Yeah, and he saw the code, and he said, "There's all these classes, these service classes. Didn't seem to be doing anything, so I deleted them all." Yeah, so he basically removed an entire layer from this application architecture. You don't want someone doing something equivalent with your cloud environment. So a service like this tells you about changes to your environment. Is your environment changed? But you can also put in here rules. So services like this, you can put in rules about how your environment should be. And if it ever deviates from the rules because somebody changed something or something happened, it can flag it. And then even better, automate a response to fix it. So wouldn't it be nice, instead of getting emails saying, oh, your environment's a bit dodgy. Oh, someone's left this port open. Oh, that bucket is public, are you sure? Wouldn't it be better if what you got was a message saying, that bucket was public, we've now just made it private again. So it's automatically fixed. If somebody left this port open, it's been automatically closed again. You know that, you get notified, but you get notified of a fix rather than notified that you've got a problem that you now need to sort out. Yeah, and that's what these kind of services you can use to do. Yeah, so automatic remediation of issues. You get the notification, but the issue is resolved for you. I remember years ago being at, I think it's the biggest public sector body in the UK. And there's a guy I was chatting to, he was just talking about this. And he said, I love this service. He said, I log in the morning, see what's been going on. I see if anyone's done anything stupid. But the good thing is it's already fixed it. So it's not like, oh, if someone's done something stupid, I've now got to sort it out. It's like, oh, someone did something stupid and it's been fixed. I'll go and have a word with that person, say, don't do that stupid thing again. Yeah, but I don't have to fix it. Yeah, because it all happened by magic. Yeah, well, it seems like magic. It's all done by the cloud provider. So you can use it to do that kind of thing if you want to. There's an advisor in Amazon as well, if you want to use that. It gives you advice around cost. We'll talk about cost later, so I won't go into it now. But it does give advice around security. Can you see security settings there with a 1 on it, exclamation mark. And then we get another service which can help us. We've got this switched on in our aviation project at the moment. We use this. We have it on in our account. So with NUIDA, we have a system that we've been using for quite a few years now where we give students a virtual machine. So if they're on a graduate program, they'll get a virtual machine that they can use for the duration of the grad program. They're meant to use it for the training. They're not meant to use it for Bitcoin mining, tour surfing, and things like that. And the funny thing is, sometimes they do. Yeah? And when they do, this thing pops up and tells us that they're doing it. Yeah, so Guard Duty is a service that gives you insight into anything odd going on in your cloud account. Yeah, now, odd can mean different things. Odd can mean, like I mentioned, a student doing something a bit dodgy on one of their VMs, which we've had. Yeah, so it could be that. It could be that somebody's logged in and deleted some databases. It would probably, that example we saw, it would pick that up. So it doesn't usually delete databases from that IP address. That's odd. It probably, can't be certain, but it probably would come up in Guard Duty. If we have a look at it, let's see what we've got in Guard Duty at the moment. We do have quite a few VMs running for students on training programs. So there may be some things. So we're in Ireland. Actually, if we go to Ireland will do. Yeah, so I've got 32 low severity warnings at the moment in Ireland and 6 high severity warnings in Ireland at the moment, and nothing in the middle. So let's have a look what counts as some of these warnings. So let's see what we got. Oh, look, anomalous behaviour. That's probably me. What did I do? Yeah, it's probably because I'm logged in from here. What am I doing logged in from here? Yeah, I've been looking at all. You remember I showed you a few things there. We went to the homepage of EC2 or VP2. We click on it. But you see, it's saying, it looks at these API calls. Unusual. I don't normally do that. So it's picking that up 23 minutes ago. Yeah, we get look at this one here. Brute force attack. If you launch a machine in the cloud and it's in a public network of some kind, you can guarantee it's going to get brute force attacks. I know that because of this. So basically, if you launch a machine, it's people going to try and log into it. So this poor machine here has been getting brute force attacks. Can you see the IP address on the right-hand side? So that IP address has been doing brute force attacks on this particular server, and it's happened 8 times. It's had 8, people trying to bang, 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 different passwords, trying to get into the thing, basically. That's happened 8 times. There's one a bit further down. 29 times. Can you see it near the bottom of the screen? 29 attacks trying to log in to this virtual machine. We can see that in the list. Some guy, can you see some bloke called Frank? Can you see that there? Some guy called Frank here. What's he been up to? He's been granting public access. Can you see that? Remember we saw the warnings about the public. Are you sure? Well, Frank, he's sitting over there. Actually, the one who liked wrestling. It's the same guy. Yeah. He's granted public access to one of our buckets. And Guard Duty's flagged it. No, it doesn't matter because it's for students to use, so it's fine. But you see, it's flagged it. Are you sure you want to do that? It's come up as a red warning. Yeah. I remember getting a warning. Anyone from No, you probably wouldn't be from Allstate. But, Allstate up in, but they've got an office in Belfast, haven't they? One of the guys I worked with was in Allstate in Belfast. I got a warning in this thing. Ian's just logged in from Chicago. He doesn't normally log in from Chicago. And I was thinking, Ian's not in Chicago. So I was a bit like, how did I manage that? But then I realised, of course, the network traffic is probably routing via Chicago because that's where their head office is. So you get warnings like that through guard duty. And of course, you can automate immediate actions if you want to. So you get a warning like this, like the bucket one there, the S3. If you wanted to, you could configure it to just immediately fix it. And turn it straight back off. So again, if you're responsible for data, that can give you some confidence. That any issues like that are getting automatically resolved. So that's guard duty. It's a useful service. It's running in real time. It runs all the time. It's not very expensive. Again, at that large UK public sector body, it was them actually who convinced me to turn it on because I was really nervous about turning it on for my corporate accounts. I was thinking it costs a fortune. But they said, it's costing us 15 quid a month. Something, well, if you're the biggest public sector body in the UK and it's 15 quid a month, I think I'll manage. And it's costing me, I don't know, $1, a couple of dollars a month. It's very cheap. So it's guard duty. It's worth turning on. Last few things. Oh, this is the last few things? Yes. Very good. Oh, we're right at the end. That's good news, isn't it? So just the last couple of things on network security. There's all sorts of things we can build in to our network as well for security the cloud providers will offer. You can replicate all your network traffic. So all your network traffic, anyone a networky person? A few of you are? So all your network traffic that's bouncing around your Amazon network, you can have all of that replicating somewhere else. So you can analyze the network traffic without impacting the actual network. Does that make sense? In addition to that, you can log all of the network traffic. So you can analyze it afterwards if you want to. So you can log all the network traffic, you can replicate the network traffic. In addition, you can create in your software-defined everything, because remember your network is software. You can create firewalls, permissions, VPNs, connections back to your data center, all this, we're talking about hybrid cloud. You're going to have public cloud on Amazon, maybe public cloud on Azure, public cloud on Google, you've got your private cloud, it all needs to be connected up. So the cloud providers obviously provide support for that through various third parties. In the UK, Virgin Media, for example, I've done some work with them. They do it. They help you set up your connection between on-premises and the cloud provider. Just so you get decent speed, etc. Then you've got firewall capabilities. So these are offered as services. You don't have to create a firewall server and all this kind of thing or buy firewall hardware. It's basically a service. And you can just block off REST traffic. Remember when the Log4j vulnerability came out with Java? It was Christmas, wasn't it? I remember it was Christmas. I was like, flip it, it's Christmas. I had an old Java Spring thing running. It was quite old. I'd never upgraded it. JSP. Do you remember? Anyone remember JSP? A few of you do. I even wrote a book on JSP. Still available on Amazon. Totally irrelevant these days. But anyway, it was JSP application. Never bothered to upgrade it because it kind of worked. And I thought, the Log4j, I better sort out the Log4j. Tried to sort it out. Of course, as soon as you do, change the libraries, boom, the whole thing doesn't work. So, tried various things. In the end, give up, stuck WAF in front of the infrastructure, and WAF has a rule to automatically block the Log4j kind of URLs or requests that you might get. So it's a sort of a stopgap. While I'll sort it out later. So just put that on. Do you see what I mean? So it'll block off SQL injection and various other things. And you can just stick that in front of your services. All sorts of different capabilities you get with WAF. We don't need to go into the details. Again, this is Amazon specific as well. They have something called Shield. This is for denial of service attacks. You can imagine Amazon customers, they're getting denial of service attacks all the time, aren't they? It must be. All the time they've got customers having denial of service attacks. So they've got Amazon Shield or AWS Shield. It kind of protects against those attacks. It's an interesting case study you can read about. I think you can read about it on Amazon.com. We certainly talk about it in the AWS security course, which I sometimes do. And in there, they talk about a customer who got a denial of service attack while there was a big conference on. It'd be like this. Imagine we're all here, and then while you are here, and the conference is about your company, and while you are here at the conference about your company, you get a denial of service attack. That's what happened to this company in the US, pharmaceuticals. So the number of servers they had ramped up and up and up. They did various things, which I won't go into the detail of. But what is interesting is the bill. The bill to deal with it, to scale up and accommodate the attack, was $2,000. And the attack was over 72 hours. And it was $2,000, which isn't bad, is it? Bargain. But that was, just that wasn't even using any of this stuff particularly. It was just the scaling up capabilities that the cloud provider offer to allow you to deal with those kind of attacks, to absorb, I suppose, the attack. You can, if you want, you can pay Amazon more money, almost like an insurance policy. They call it Shield Advance, but basically you pay them a fee, and if you get a denial of service attack, they are on it like a rash. Yeah, they're all over the attack, and they're helping you mitigate it, and any costs, you don't have to pay them. Yeah, because you're paying for that team to be on it. You also get a dashboard which shows you where in the world denial of service attacks happening at the moment on Amazon. So you can see what's going on, what kind of attacks are taking place. Yeah, you get that if you want to pay them a bit of extra money. What about our application code itself? There's various things we can do for the applications themselves. We can use load balancers to protect our application from external threats. You can go for serverless architectures, for example. We haven't got time to go into the detail, but you can do a serverless architecture where your attack surface is significantly reduced because you're not running any servers. We talked about patching servers. What servers? There aren't any. If you do a serverless, the clue's in the name, isn't it, really? Serverless architecture, no servers. Obviously, there are servers. It's not literally the cloud, is it? So there are servers, but they're not your responsibility. You've got no visibility on them at all. But you can build entire applications and deploy them. It can be very cost effective, depends on what you're doing. It can be very expensive, actually. Depends what you're doing. And some applications really lend themselves to this. Some really wouldn't. It depends on your architecture. Yeah. But from a security point of view, one of the real benefits is just the attack surface is so small in a serverless architecture. But that's a topic for another day. 2:43. I think I need to shut up. Yeah. That was an hour, wasn't it? 2 minutes. 2 minutes left. So I did at the beginning I said I wouldn't take the hour, didn't I? 58 minutes. Yeah, sorry. Is there any questions or anything? You just want to go and have a break, don't you, probably? No, that's good.
So thanks a million, Nick. That was really insightful and a good journey through